Welcome back to Vuln Vibes. In this deep dive, we are going to talk about NTLM hash leaks. Specifically, we're diving into CVE 2025-24054. Now this should really make security architects sit up and listen. Because what we're looking at today, it's not your typical code bug or, a buffer overflow. It's more architectural. It turns a really common thing, just extracting a zip file into a zero-click way to leak credentials. So, our mission today: unpack how this works, how it gets past usual defenses, and maybe why the Windows trust model is kind of the weak point here.
Yeah, that framing is spot on. Whenever an OS tries to automate things for convenience, well, it can sometimes create these dangerous implicit trust situations. And this vulnerability is sitting right inside Windows Explorer and its indexing service.
Yeah.
It's a perfect storm, really, weaponizing default behavior. And it's not theoretical, right? We're hearing reports of active exploitation. So, yeah, teams need to be thinking about hardening, like yesterday.
Okay, let's clarify that interaction model, though. Because zero-click sometimes sounds like absolutely nothing happens. We call it zero-click credential leakage. But just to be super clear for everyone listening, the user does have to do something, right? Like extracting the archives.
Absolutely. That distinction is important, yeah. The user performs one small action, maybe extract all. But the crucial part is there's zero interaction needed with the actual malicious file inside that archive afterwards.
Okay.
The system takes over. It's passive from the user's point of view at that stage. So the attacker hides this specially crafted file in a normal or error. Victim extracts it. And then, boom, back-end services. They just wake up and start the leak process automatically before the user even maybe looks inside the extracted folder. That's what this CVE, the 2402541, really target, that gap between extraction and the system indexing it.
Got it. And before we get into the nitty-gritty of the setup, just a quick housekeeping note on the CVE number itself. Seems there is some confusion.
Yeah, good point. So the official one now is CVE 2025-24054, but you might see older references, maybe in internal logs or some early bulletins mentioning CVE 2025-24071. Same vulnerability, just an identifier change. So if you're checking patch histories, maybe search for both just to be safe.
Okay, good tip. Now, the payload file itself, it's not an exe, not a DLL. It's a .library-ms file, which is basically XML, right? Windows uses it for defining library locations, search scopes. Seems pretty harmless on the surface. What makes this file type the weapon?
It's all about how Windows treats it. It's that implicit trust again. See, the OS doesn't really see .library-ms as user content needing a security scan. In the same way it sees an exe, it sees it as configuration, like instructions. Here's a location I need to know about. And if that location is defined using a UNC path, a network path, the OS just tries to resolve it instantly. It's designed for speed, for indexing, but that completely skips the usual should I run this checks.
Right, because it's not running anything in the traditional sense. It's just looking up a location. Okay, let's walk through the attack chain. How does the attacker set this up?
It's disturbingly simple, actually. Step 1, craft the .library-ms file. It's just XML. Inside that XML, they stick a specific tag, a path tag. But instead of pointing to, C music, it points to an external SMB share they control. Attacker address and share. Could be any IP, really. And that server is just sitting there listening.
And step 2 is just zip it up. Maybe give the zip file an innocent name.
Exactly. Make it look like payslips or project files, whatever.
So the victim gets it, does the extract all. What happens on the system then? Which process actually triggers the leak?
Okay, so the extraction finishes. Files land on the disk. That immediately triggers background services, specifically the Windows indexing service. The main process involved here is usually search protocol host.exe. Its job is to scan new files to keep the search index up to date.
Oh, okay.
When it sees that .library-ms file, it reads the XML, finds that UNC path, and it immediately tries to connect to it. To, check the library's content, see what's there.
Wait, how immediate is immediate? If I extract, realize, whoa, that file looks weird, and hit delete really fast, can I stop it?
That's the scary part. Usually no. The indexing is built for speed. The moment that file exists on the disk, search protocol host.exe is likely already processing it. The attempt to connect to that attacker-controlled SMB share, that initiates the NTLM SSP negotiation, NTLM security support provider. Basically, Windows tries to authenticate to access the share.
And in doing so,
it sends the user's NTLM v2 hash right to the attacker's waiting server. It's automatic, passive credential harvesting, often done before you even close the extraction window, even dragging it to the recycle bin. The damage might already be done because the connection attempt happened the instant it was indexed.
Wow. Okay, so post-exploitation. The attacker has the NTLM v2 hash. For folks maybe more used to dealing with Kerberos environments or who think NTLM is purely legacy, why is leaking an NTLM v2 hash still a big
Oh,
deal?
it's absolutely still a big deal. Two
Mm.
main reasons, really. First, offline cracking. If the user's password isn't super complex, or maybe it's reused from somewhere else that got breached,
Mm.
attackers can take that hash offline and throw cracking tools at it. Dictionary attacks, brute force. They might get the clear text password back.
Which is obviously bad. What's the second reason?
Pass the hash. Or NTLM relay attacks. This is often even more dangerous inside a corporate network.
Right, pass the hash. They don't even need the password itself. They just reuse the hash.
Exactly. They take that captured hash and use it directly to authenticate to other systems or services on the network as that user. They're essentially impersonating the victim without ever needing to crack the password.
And if that victim has admin rights somewhere,
Game over, potentially, or at least a major foothold. If it's a local admin, they can move laterally to that machine. If it's a service account, they might access sensitive data. If, heaven forbid, it's a domain admin, well, the attacker practically owns the network at that point. And because the initial leak is so low friction, just extracting a file, it's perfect for wide-scale phishing. High success rate potential.
and this wasn't just a theory, right? Sources mentioned this got weaponized fast.
Oh, yeah. Very fast. Reports popped up pretty quickly about a threat actor, I think called Kryptono.
Hmm.
Apparently, they were selling this exploit, maybe even bundled with a tool to make it easier to use. When you see an exploit that twists a trusted system function like this get productized and sold, serious. It's being used in the wild.
Okay, so active exploitation means mitigation is critical. Top priority, obviously, is patching.
Absolutely. Number one, non-negotiable patch. Microsoft fixed this in the March Patch Tuesday release. Get that patch deployed everywhere, all affected Windows versions. That's the definitive fix. It stops the .library-handler from automatically resolving external paths like this.
But patching isn't always instant. Legacy systems, rollout schedules. What can teams do right now if they can't patch immediately? Or just for defense in depth?
Okay, several tactical things.
Yeah.
First, network monitoring. Get strict on egress filtering. Watch for outbound SMB traffic, especially from workstations, going to unexpected external IPs. That should be a huge red flag, correlated with file activity if you can. Did an SMB attempt to a weird IP happen right after a user extracted a zip? Alarm bells.
Makes sense. What about tackling the indexing service itself?
Yeah, if your organization doesn't actually use the Windows libraries feature heavily, you can limit the attack surface there. You can configure the Windows search indexer, maybe via group policy or registry tweaks, to just .ignore .library-hams files. Or at least don't let it automatically index them or follow paths from them. If the feature isn't critical, disabling its risky part makes sense.
What about EDR endpoint detection and response tools? Can we build specific rules for this?
Definitely. You need a rule focused on the process behavior chain. Look for this sequence, explorer.exe, or an unarchiver process spawns, followed quickly by search protocol host.exe. And then search protocol host.exe makes a network connection, specifically an SMB connection, port 445, outbound to an external or non-standard internal IP. That specific sequence is highly suspicious. Search protocol host.exe usually talks locally or to internal domain controllers file servers, not random internet IPs.
So flag that specific chain of events.
Right. Flag it, alert on it, maybe even block it if your EDR allows and you've tested it. Doesn't break legitimate workflows.
And the basics still apply, I assume?
Always. User education is still key. Be wary of unexpected archives from unknown sources. Don't just extract everything. And internal SMB hygiene. Audit your shares. Apply least privilege rigorously. Minimize external SMB exposure completely if possible. Even if they get a hash, make it harder for them to use it via relay attacks internally.
You know, this whole incident is such a stark reminder. Attackers aren't just hitting executables anymore. They're cleverly subverting these built-in trusted features, turning convenience against us.
It really underscores how vital it is to scrutinize that trusted attack surface.
Mm-hmm.
We focus so much on macros, on executables. But these seemingly benign config files, metadata files, if the OS trusts them implicitly and acts on them automatically, especially involving network paths, they become potent weapons. It's that implicit trust that gets exploited.
So the final thought for you, our listeners, the secure pros out there, this whole thing hinged on a non-executable file type that Windows automatically processed, .library-lanus. It really begs the question you should be asking right now. What other file types, maybe XML, INI, config files, does Windows, or maybe even third-party software on your endpoints automatically parse and potentially act on network paths from, just on extraction or file modification? Because the next zero-click leak might be hiding in plain sight in another one of those trusted definition files nobody's really scrutinizing. Time to audit those handlers.